Good to see everybody. Thanks for coming down. I've got a little bit of an introduction I want to make for our speaker, and it's my privilege to introduce Professor Lanmin Wang from the Lanzhou Institute of Seismology. It's his third visit and his second presentation. 2 years ago, he spoke about the Winshan 8.0 earthquake and the recovery and scientific investigations from that huge event in China. So he's been here before. It's his third visit, and we're always pleased to have you visit. He's a longtime partner with us. In 2005, the University of Kentucky and the Lanzhou Institute of Seismology signed a scientific partnership, which we have now conducted for 7 years. As part of that agreement, we have hosted visiting scholars from the Institute in China, and Qin Li is our current in-residence visitor from Lanzhou. And we have done research in China and in the US on seismology issues. I think we have counted 10, 11, 12 scientific papers in progress or completed so far. So our production keeps moving on, and we're very proud of that. It's sort of a three-way agreement. The agreement includes KGS, but it's between the University of Kentucky and the Lanzhou Institute, so it's like three-way. KGS, UK, and Lanzhou. Dr. Wang is currently at the Harvard Kennedy School of Government doing a one-semester study of earthquake response and mitigation. Now this is something you can't make up. But on October 28th, Sunday, I'll never forget, it was a Sunday, Dr. Wang and I met in Washington, D.C. And we did a tour of the mall and the Lincoln Memorial, the Vietnam Memorial, the World War II Memorial. And about the time we got to the Capitol, taking pictures, the wind picked up, there's a little bit of rain. But we jumped on the subway and made it back just as Hurricane Sandy hit. So for the next 2 days, we were pretty much housebound. Well, I figured, you know, everybody from China can cook, except Dr. Wang. He must be the only person. On the first floor of where we were staying, there's a Korean restaurant. We got the last loaf of bread and a carton of milk before it completely sold out. But we bought food, and we learned a little bit about cooking. And so we survived for 2 days. We emerged after the hurricane hit. Trees were down all over the parkings. Shingles had been ripped off. They're kind of covering the street. We had set up some wonderful visits with FEMA, NEHRP, USGS. None of them, they were all shut. But we did get one visit with the American Geological Institute, which was really nice. So that worked out. But we witnessed firsthand response, emergency response to a national disaster. Because our TV was on and we could watch as this whole thing unfolded. It wasn't an earthquake, but it was a national disaster. Dr. Wang is the director of the Lanzhou Institute, which has about 500 employees. They have several hundred seismic stations, plus stations measuring many other parameters of earth science. So Gansu province is where Lanzhou is located, about 3 times bigger than Kentucky. It has a huge diversity of topography and terrain. 17,000-foot peaks, desert, lush plateaus, got the Yellow River. The Yellow River flows right through Lanzhou. Archaeological antiquities of all kinds, amazing treasures from antiquity. It's also got the end of the Great Wall. The Great Wall of China stops in Gansu province, and we had been there. We had visited that. It's also got the Chinese home of Marco Polo. Old Mark hung out in Gansu province for 10 years, they say, a little bit. In 2006, the trip we took to Tibet in 2006, we wrote an article for Earth magazine about the railway going from Qinghai province to Lhasa, which was published. In 2008, the Lanzhou Institute was a first responder and worked on the recovery of the Wenchun devastating earthquake that was centered in Sichuan province, but I think you told me 40 counties.
Yeah, 44 counties.
44 counties in Gansu province were greatly affected by that earthquake. Today's talk, Dr. Wang is going to speak about the Zhouqu debris flow, which also cost about 2,000 lives in southern Gansu province near Lanmin. I've been there. So I give you Dr. Wang.
Thanks, Jim, for your kind invitation and introduction. It's my great pleasure to introduce the devastating debris flow of Zhouqu, China in 2010. The 5 parts will be involved in my presentation. First part, I would like to introduce the characteristics of Zhouqu debris flow. Zhouqu County is located in southeast Asia of Qinghai Tibet Plateau, south part of Gansu province. The elevation ranges from more than 1,000 meters to 4,500 meters. Zhouqu County is located in a tectonically and seismically active region. Zhouqu County is located in one of 4 debris flow prone regions with highest frequency of debris flow in China. We can say that those red points denotes each event of debris flow in China. Sorry. Gansu province have a highest frequency of debris flow. At midnight of August 7th, 2010, a heavy rainfall of 77 millimeter in 1 hour triggered tremendous debris flows along 2 ravines in the north part of Zhouqu County. 2 villages with 300 houses were completely destroyed. Other 4 villages with 700 houses and 21 buildings in the city were seriously damaged. 1,765 people were killed. More than 20,000 people were affected. Traffic, communication, water, and power supply were destroyed. Lanzhou River channel was blocked. The dammed river water flooded 1/3 of the city for several days. It is China's worst debris flow disaster in recent 6 decades. The 2 pictures shows the site before the disaster and after the disaster. Overhead views shows the big mudslide which occurred at Lanzhou Ravine. This ravine is a larger one, and another is a smaller one named Lanzhou Ravine. Nearly split the city into two parts, and flattened the area with 5 kilometers long and more than 500 meters, 5 kilometers long and more than 500 meters wide. Yeah, this picture shows the main parts of the debris flow of Lanzhou Ravine and Lanzhou Ravine. All of the houses and buildings on its path were buried and destroyed. This picture shows the main stream of debris flow in Lanzhou Ravine toward the county city. The debris flow pushed the buildings collide each other. Some buildings collapsed by the collision. This is a destroyed public building on the left flank of debris flow. This middle school building were damaged seriously by the debris flow. We can see that part of the building collapsed, and the first floor was filled by mud. The houses on the flanks of debris flow were filled with mud. Second part, I would like to introduce the characteristics of Zhouqu debris flow. This debris flow have a very large affected area. The scale is very huge. And it is located in the winter earthquake hit area. The debris flow induced a secondary disaster, which is a flood in the county city. We can see that the red line counted the affected area. The total area is about 2.4 square kilometers. We divided the affected area with 3 grids. In grid 1 area, we call it extremely serious disaster region, where is the main path of debris flow. Most of buildings and houses were destroyed or buried completely. The area is about 1.2 square kilometers. Grid 2 is a serious disaster region where houses were damaged seriously but did not collapse, which is located in the 2 flanks of the debris flow. The area is about 0.2 square kilometers. Grid 3 is general area where the buildings did not damage. Just flooded or filled with mud flow. The area is about 1.0 square kilometers. This picture shows grade 1 area affected by the debris flow. We can see that this area was flattened by the mudslide. And in this area, all the houses and the buildings were buried completely. Those buildings is located in grade 2 area, where is flanks of debris flow in the two sides, partly damaged, and the first floor filled with mud. On the flank of debris flow, some houses moved by the mudslide and shared damage. Walls, pillars, and the foundations of the building or houses were shared off by the flanks of the debris flow. So this is also located in the flank of debris flow, wall collapse or crack. Only one survived house on the main part of the debris flow was reconstructed with a seismic code after Wenchuan earthquake. So we can see that the seismic measurement can make the house against the earthquake, also can defend flood and debris flow. The scale of debris flows is huge. Sanyanyu Ruwan debris flow is a larger one. Destroyed the area 5 kilometers long and more than 500 meters wide. 95% of casualties were caused by this debris flow. The maximum flow rate at the mountain pass was about 2,000 cubic meters per second. The accumulated fan is about ranges from 80 to 260 meters wide, 2.2 kilometers long, and 1.5 to 4.5 meters thick. The volume of mudslide was about 1 cubic meters. The Lanzhou debris flow is a smaller one. The volume of debris flow was around 310,000 cubic meters. The casualties is around 80. We can see that so huge rocks and debris carried by the mudslide in Sanyanyu Ruwan. This debris flow desired site is located in Wenchuan 8.0 earthquake affected area. From the mesoseismal map of Wenchuan earthquake, we can see that Zhouqu County is located in the 7 to 8 degree of earthquake intensity zone. The debris flow from Sanyanyu Ruwan and Lanzhou Ruwan flowed into Bailongjiang River and made the river water rising and flooded 1/3 of the county city in this region. Yeah, this is a flooded street. Part 2, I would like to introduce the emergency response after the disaster. After the disaster, central government, provincial government, city government, and county government started the emergency response immediately. In the disaster field, a different level government organized a unified commander headquarters. The unified commander headquarters composed of different level government officials. They had a very good performance during emergency response to Zhouqu debris flow. During the emergency response, totally there were 30,600 persons involved in rescue and relief work, including Army, police, Army Reserve, volunteers, and professional rescue teams. The second action was from the unified commanding headquarters, a series of instructives gave to the rescue and relief workers. First action was searching survivors and rescue victims. The second action was dredging the dammed river channel. The third action was transporting the relief goods and sheltering the victims. Because the flooded urban area mud covered the streets and a very, very crowded city made transportation very difficult during emergency response. Even vice premier was took by this machine to the headquarters. The fourth action was cleaning up the debris deposit on the streets. The fifth action was disinfection and epidemic prevention. Our institute also named Gansu Earthquake Administration, coordinated and assisted China International Search and Rescue Team to carry out emergency rescue action in Zhouqu debris flow. The provincial top officials were arranging the rescue tasks for the China rescue team. Our administration and institute was coordinated both national rescue team and the provincial rescue team to searching and rescue victims at the site. Our institute also organized a field investigation on the debris flow. Third part, I would like to introduce the causes of the debris flow. I will mention the following 5 factors to generate the debris flow. First is the topographic condition. The topography of the Sanyu and the Luojiayu ravines are abrupted slope and deep valley. The configuration of ravines look like a round-backed armchair, of which the upstream is wide and downstream becomes narrow and narrow. High mountain and steep slope are essential landform of developing debris flow. We can see that the vertical height of the slope in Lanzhou Ravine is about 458 meters. The vertical height of slope in another ravine, Zhouqu Ravine, is 403 meters. The slope in Lanzhou Ravine is very deep, so we can see that here is about 82 degrees, and most of the slope is above 60 degrees. Veined or U-shaped ravines are typical topography in the developing region of debris flow. This longitudinal section shows the slope at the bottom of the ravine is also high, which is about 35 degrees. The longitudinal section in Zhouqu Ravine, small one, the slope of bottom is also higher, around 20 degrees. The investigation shows the upstream branches of the ravine with high sloping in different sections. We give figures here. We can see that those large slope ratio is favorable for development of debris flow. The valleys of debris flow stretched from north to south, higher in north part and lower in south part. We can see that elevation is, here is about 3,828 meters. At the mountain pass, elevation is about 1,550 meters. At the bank of river is about 1,320 meters. So we can see the difference in elevation is too much. Here is a location, two upper branches meet together. The width is about 300 meters. But at the exit of Lanzhou Valley is 26 meters wide. So we can see that when the debris flow rushed out of the mountain pass, how large the energy was accumulated. And this is the Zhouqu Ravine. This here it also have a very high elevation, which is about 3,794 meters. Here is the exit of Lanmin. Elevation at the mountain pass is about 1,600 meters. And here is a river bank. In the exit of Lanmin, the width is about 7 meters, much narrower than the upstream. The above-mentioned investigation shows that the slope of source region of debris flow is generally above 50 degrees. The bottom sloping along the ravines are greater than 20 degrees for the branches and above 10 degrees for the main ravines. This kind of landform is prone to collect water and soil fluid from upstream. The high mountain, steep slope, and narrow downstream channel make debris flows high mobilized. Zhouqu County is located in area with active tectonics. We can see that the deep and the large regional Bailongjiang active fault belt crosses Zhouqu County. The loose loess on the top of the slope, detritus of mountaintop layer, and deposit materials in the valley are the main sources of the debris flows. We can see that those top deposit in Lanzhou. The top deposit is loose detritus. Second layer is clay silt. Third layer is fractured slate. Bottom is integrated slate. Along the ravines, there were rich material resources. One reason for so many material resources is due to earthquakes. Earthquakes in history induced many collapse and landslides and cracked rocks of the slope, provided rich materials for the debris flow. The accumulated material from the old debris flows reached 800,000 cubic meters per square kilometers on average, which enlarged the resource of debris flow. There are more than 50 so large accumulated deposits in the two ravines, of which the volume exceeds 3 million cubic meters. Accumulated rocks and soil blocked by the old dams enriched the material of the debris flow. Below the disaster, some small dams were built along the ravine. Another reason is less vegetarian on the slopes of the mountain made the topsoil erode seriously. Fractured rocks are easily washed down to the bottom of ravines by rain storm and accumulated into resources of the debris flow. We can see that in history, Zhouqu and the nearby area were affected by strong earthquakes. In history, there are 4 larger earthquakes affected Zhouqu with intensity of 7 to 9. One is Wudu 7.0 earthquake. Second is Tianshui 8.0 earthquake. Third one is Wudu 8.0 earthquake. Latest one is Wenchuan 8.0 earthquake with in Zhouqu County. This map shows the earthquake intensity distribution of Wudu 7.0 earthquake in history. The epicenter is 20 kilometers away from Zhouqu. During Wenchuan earthquake, 44 counties in Gansu province were seriously damaged. Zhouqu is 3 most damaged county in Gansu province by the Wenchuan earthquake. We can see that this is the location of the Zhouqu County. So the loose noise, detritus of surface layer, and accumulated materials created very rich resources for the debris flow. The triggering factor is rainfall. Torrential rain happened instantaneously at the midnight of August 7th. The hourly rainfall reached up to 77.3 millimeters from 11 p.m. to 12 p.m., which had been at 12 a.m., which had been the maximum rainfall intensity since local weather station set up. The first part I would like to introduce the reconstruction. After rescue and relief work finished, the central and the provincial governments jointly compiled the reconstruction plan for Zhouqu County. The total reconstruction fund is about $800 million US. Why the debris flow caused so many casualties in Zhouqu County City? Just because one of reason is overpopulation. Before the disaster, there are 500,000 people lived in the county city. Actually, experts gave an evaluation about probable population is about 30,000 people. So during the planning for reconstruction, the government paid more attention about the population. The plan induced the population in old county city and developed a new area near the old county city as a reconstruction site. So totally, the government planned 4 sites for reconstruction. 3 of them is located in Zhouqu County. 1 of them is located in Lanzhou City, capital of Gansu Province. Just because this county dominated by Tibetan people. So the local government wants to improve the education quality for Tibetan students, take opportunity of reconstruction. So the plan moved the middle school and high school in Zhouqu County to Lanzhou. All of the students moved to Lanzhou for their education, for their study. And the 3 sites for reconstruction, 1 is located in Old City. Here is nearby the Old City. The 3rd one is located here. In Old City, we can see that the plan divided the area for different purpose. The main path of the debris flow is kept for Memorial Park. And cleaning and drainage channels, a large scale of drainage channels were built along the debris flow path. Which is a defensive project for debris flow in future. And this red area is business development area. Brown color area for reconstruction project. And the soil color area is present reservation region. That means during the disaster, most of buildings and houses in this region were in good condition without serious damage. Those areas slight yellow color area is removed area. Those area is prone to flood disaster in future. So government decided to move all the villagers and citizens who lived in this region to a new reconstruction site. This map shows the reconstruction plan for a second new site. We can see that primary schools planted here, and commercial services buildings planted here, and residence buildings is planned here. And also a dam along the Lanzhou River were built during Reconstruction. For the Reconstruction, geological and seismic hazard survey, prevention, and the early warning system were considered in the plan. The detailed surveys carried out in Zhouqu County to figure out potential geological disasters and seismic disasters in Reconstruction region. Based on the survey, a series countermeasures were implemented for protecting people from the disaster in the future, such as keeping buildings away from active faults, constructing blocked dams, embankments, and debris flow channels, stabilizing slopes, dredging riverbed, and revegetation. Yeah, this is a blocking dam constructing after the disaster. We can say that two of large drainage channels for debris flow in the future were constructed along the main path of the Zhouqu debris flow. It is 2 kilometers, more than 2 kilometers long, and 32 meters wide. The channel has been finished this year. Based on the active fault detecting, our institute figured out 3 active faults across the Zhouqu County. 2 of them, F1 and F3, are active faults. Buildings and houses should be keep 50 meters in each side away from the active faults. And also, as a part of Reconstruction, technical monitoring and early warning system has been constructed or improved in Zhouqu County, including geological, seismological, meteorological, and hydrological monitoring networks. Conclusions and lessons. The extraordinary Zhouqu debris flow occurred on August 7th in 2010 is the most severe debris flow event in 60 years in China, which caused a tremendous loss in people's lives and properties. Field investigation, remote sensing image interpretation, and local meteorological data and analysis indicated that there are 5 main causes of catastrophic debris flow as follows. One is topographic conditions. Second is massive debris sources. Third, torrential rain. Fourth, earthquake effect. Last one is less vector on the slope of the mountain. We also get some lessons from the disaster. First lesson is that land use and city planning should highly consider natural disaster prevention and keep buildings and houses away from potential disaster regions. Second, the systems for disaster prevention, monitoring, and early warning should be constructed in natural disaster-prone regions. Third, along the up and middle reaches of Balonjiang River, which is a debris flow prone region, ecological environment should be improved and reconstructed. Last slide, I would like to show a reconstruction project in Wenchuan earthquake affected city, and Zhouqu debris flow destroyed county city and villages with a new image. So those projects give a bright future for disaster-affected regions. Thank you.
Are there questions? Man.
How does the 77 millimeter rainfall event compare to
Per hour.
other events
Per
throughout
hour.
the year or seen different seasons? Is that a record rainfall event or?
In Gansu province, the average rainfall per year is about 300 millimeter. In Zhouqu County, it is about 400 meters. So that means in 1 hour, the rainfall occupy nearly 1/5 of the year rainfall. That is why if the rainfall happened in South China, there I think there is no disaster occurred there, just because in this region there is less rainfall can be reached to so tremendous quantity. So in history, if the area have rainfall with so quantity per hour, debris flow would be induced by rainfall. And also in this year, some little scale of debris flow were induced by rainfall. But rainfall is less than Zhouqu.
Other questions? I've got one.
Thank you.
How much time did it take for the debris flow?
There is no accurate time, just because the events happened at midnight.
Was there any
Most
warning?
of the people was sleeping, was sleeping. But some experts estimated the speed of debris flow is very fast, just because the people have no enough time to respond to the debris flow. I just take an example. One of KTV room is located in north region of county city. Before the debris flow come to the KTV room, there are more than 10 young guys were singing and dancing in the room.
That's KTV is karaoke. Karaoke.
So when the mudslide came into the room, all the space in KTV were filled with mud. Debris immediately. When soldiers, singers, and dancers, they keep a different body shape. They have no any response to
So fast.
So fast.
Did the flow create a seismic recording on your station?
Yeah, we have. We recorded a small shaking before the event. But after the event, our seismic station just located at near the main the mountain pass of Lanzhou Wang, larger debris flow. Fortunately, the debris flow stopped at the front gates of our seismic station just by several meters. So one of our colleagues was on duty in that night. He shocked by the event. Yeah, and he immediately climbed the top of the mountain near the seismic station.
You have a recurrence interval from historic record, from observation.
Yes.
Any other, ma'am?
I'm sure there are thousands of seismically induced slides. So is there a way of knowing how many earthquake-induced slides are up in the mountains that you could just sort of generally say this is an area that is susceptible to debris flows because there's these loose landslide deposits? Or is there a way of knowing that?
Yeah, in history, there are many strong earthquakes with magnitude greater than 4.7 magnitude. As you know, in China, we call earthquakes greater than the magnitude of 4.7 as a strong earthquake. In that region, just because Bailongjiang river active faults across the county, many earthquakes occurred in the county or nearby area. I mentioned four of them large earthquake with magnitude greater than 7. Those earthquakes made the top soil, top rock on the slope fracture. And but I think the most influence from Wenchuan earthquake, because in history there are several big debris flow occurred in both domains. The historical earthquake induced some landslide and fractured top soil of slopes. Just brought away by a historical debris flow. So before Wenchuan earthquake, there is no major earthquake influenced in this area. So the earthquake intensity induced by Wenchuan earthquake in this county is strongest one. Intensity range from 7 to 8. Actually, in Gansu province, there are 3 counties were recognized as the most serious disaster region caused by Wenchuan earthquake. Zhouqu is one of the 3. So, but in the long historical period, many small earthquakes, I think, induced some small scale of landslides, made material accumulated along the riverbed. So, so large deposit, debris deposit, just along the riverbeds, but there is no large rainfall bring them out. So this event, just because the biggest rainfall bring all the deposits along the riverbeds out.
Anything more, Seth?
You mentioned that you would like to have some kind of early warning system set up for debris flows, and that would include multiple kinds of sensors, multiple networks. How would that work? What could you hope to accomplish, and what would be the triggering mechanism for this kind of event?
Oh yeah. Early warning system was integrated technical system. Include seismic station, ground motion station, meteorological station, and geological observation system. So all the kind of natural disaster which frequently happened in this region will be monitored. For example, in meteorological station, the meteorological bureau will give early warning signal based on rainfall. They established a standard for triggering value of the rainfall. If a rainfall is larger than some critical value, the debris flow will be alerted. And for debris flow observatory system, this is managed by a department, a special department of government, which named Department of Land Use and Resources. And this department set up many observatory instruments along the banks and valleys. So those technical systems will give early warning signal to local people. And the local people will release the information immediately by mobile, cell phone, internet, and broadcast. And for seismic station, we try to carry out two kind of early warning work. One is for earthquake, and another for debris flow. That's because we recorded some small tremor before debris flow event. We believe that is small slide induced by rainfall from upstream of the debris flow. So we try to develop a technical method to make early warning signal for debris flow based on the tremor, small shaking before debris flow event. But the problem is how to recognize the signal of landslide and ground shaking. Yeah, that is the problem.
I mean, we have a little gift for you
Oh, thank you.
for coming.
Oh, thank you. Thank you. Thank you.